Subscribe and press the bell icon to never miss an update. Hello everyone, this is Meghna from getsoftwareservices.com. At GSS, we provide extensive training on different software testing concepts like QA, business analyst, automation testing, performance testing, web service testing, mobile testing, etc. So please do visit our website for more details on the courses. So today's session I'll be telling you about black box testing, white box testing, gray box testing. We'll be learning what are these testing types. So let's get started with the session. So first let's understand what is black box testing. Black box testing is a method of testing the software without getting inside the coding details of the application. So all the code logic, design of the application is inside a black box. As tester, we will not get to see the code or the implementation of the application. Without getting inside the internal details of the application, you test it. Just like an end user, you give the input and check if the output is correct. You're not bothered about which programming language is used, how the code is written. We are not bothered about those things. We just give the input and check if the output is correct, if the output is matching with expected. So that we call it as black box testing. And to do black box testing, we write test cases where we mention the steps that should be done to test the functionality of the application. Based on the requirements, test cases are written, and then these test cases are executed by giving input to the application and checking the output, checking if the output is matching with the expected result, if it matches with what is mentioned in the requirement specifications. So that is black box testing. So example I can give you for black box testing is, now let's say if you're watching a movie. When you're watching a movie, you should be able to hear the audio, you should be able to see the video. Audio and video should be in sync. Now you're not bothered about how the movie is made, what technology is used, how it is getting projected on the screen. We're not bothered about the internal details. We should be able to see the video, we should be able to hear the audio, audio and video should be in sync. That is exactly what we do in black box testing. We test the application without getting inside the coding details. That is black box testing. So as manual testers, we do black box testing. There are different techniques that you can apply when you're doing black box testing. Now, what are testing techniques and why they are required? Now, when you're testing an application, you should know what is the right amount of tests that you should do. I cannot test application with all possible values. So that is why these testing techniques are applied. So you can limit the amount of testing that you're going to do on the application. At the same time, you can find large number of bugs. There are different black box testing techniques. The first one is boundary value analysis. Boundary value analysis is a testing technique which is applied at the boundaries. Now let's say for example I have an application with a password field and it accepts values 8 to 20. The password field allows you to enter a password of minimum 8 characters and maximum 20 characters. Now with what all values I need to test this text box? I will apply boundary value analysis and I will derive this formula n plus 1, n minus 1, where n is the boundary. So I'll test with n, that is 8, n plus 1 9, n minus 1 7. I'll test by entering password whose length is 7, 8, 9. And then I'll also do the same thing on the upper boundary which is 20. I'll apply the same formula and I'll test it by using password whose length is 19, 20 and 21. So I'll be doing 6 different tests to test the password field. So you're testing at the boundaries. That's because developer tends to make more mistakes at these boundary values when he's writing the code. The second testing technique we have is equivalence class partitioning. This again is applied on the test data where you have range of values to provide. Now in equivalence class partitioning, we divide our test data into classes and we pick one sample from each class. And if that works, we assume all other data in that class are also going to work the same way. Now, if we were to take the same example for the password field, which accepts 8 to 20, I will divide it into 3 classes. One number less than 8, one number which falls between 8 and 20, and one number greater than 20. So I'll pick any number less than 8 and see if the application throws error because minimum value is 8. I'll pick any number between 8 and 20 and check if it is accepted. And I will enter any number greater than 20 and see if it throws error message because maximum allowed is 20. So you divide into 3 classes and pick one sample from each category. That is equivalence class partitioning. Now the next testing technique we have is decision tables. Decision table is used to derive test based on different combinations. So when we have to derive our test on different combinations, there's a high possibility that we might miss one of the combinations. To avoid that, decision tables are used. Now let me explain this with a simple example. Now let's say there is a requirement which says you can give rental car to a person whose age is greater than 23 and has a clean driving record. Now I need to do test who should be given the rental car and who should not be given the rental car. So I will write a decision table like this. So I can test all the combinations. If age is greater than 23 and has a clean driving record, if age is greater than 23 and has a clean driving record, then he should be supplied with rental car. What if a person's age is greater than 23 but he does not have a clean driving record? Then he should not be given a rental car. What if his age is not greater than 23 but he has a clean driving record? Since his age is not greater than 23, he should not be given the rental car. If his age is less than 23 and does not have a clean driving record, again he should not be given the rental car. So I can test with all combinations. When I write it in the form of a table, I'm not going to miss any combination. So you write your conditions, you write the output and check for each true false value. That is decision table when you have combinations to test. And the last testing technique we have is error guessing. This is a very simple technique where you randomly test the application without following any formal test cases. So based on the tester's knowledge, based on tester's experience, you test the application. You guess, okay, this is the area where I can find bugs. Maybe when I give this kind of data, I may be able to find defects. So you're randomly testing the application without following any formal test cases. So that we call it as error guessing. So these are different black box testing techniques that we have. And in all these testing techniques, if you see, we are not getting inside the coding details. That is why it is called as black box testing. Now the next testing type is white box testing. So as the name says, white box is just the opposite of black box. It is also called as glass box testing. In white box testing, we go and test the code itself. When you test the code, then it is called as white box testing. So here, the person who is doing white box testing should have a good knowledge of the code that is written. When you test the code, that becomes white box testing, which is also called as glass box. Now there are two white box testing techniques. One is statement coverage and the other one is decision coverage. Now, since white box testing involves testing the code, in statement coverage, what we do is we write down test cases in such a way that it covers all the lines of code that is written. You need to write test cases which can test all the lines of code. That is statement coverage. Now, how many test cases are required to achieve this 100% coverage? That can be calculated using this formula: number of statements that will be covered divided by the total number of statements that are there in the code into 100. So basically, in statement coverage, what we do is we first write down the test that can cover different lines of code, and we check with these test cases how many lines can be covered. And if we achieve 100% coverage, that means the entire code is tested. That is statement coverage. The second one is the decision coverage. Decision coverage is applied where you have if conditions. You will have true or false value. If this is the case, then this should be done. If this is the case, then something else should be done. So when you have if and else conditions, that is when decision coverage is applied. So in this technique, we write our test in such a way that it covers both if and else condition. If age is greater than 23, what should be done? But I also need to write a test which covers what happens if age is less than 23. So I will have two decisions to coverage: age greater than 23, age less than 23. So I'll need two test cases to cover this decision. So that is decision coverage. So here, based on the lines of code, statement coverage and decision coverage is done. Statement coverage will ensure that all the statements in the code are tested. Decision coverage will ensure that both if and else conditions are covered. And both are white box testing techniques. The last one you have is gray box testing. As the name says, gray box is a mix of black box and white box. A mix of black box and white box gives you gray box testing. Now here, you get to test the application like an end user. At the same time, you get to go inside the code and test the coding part as well. Gray box testing is usually done as part of integration testing and security testing. So when you're doing integration testing, when you're testing the integration of the modules, or when you're testing how secure is the application, that is when you may have to test as an end user. At the same time, you may have to go inside the application and check the design of the system. So mix of both, we call it as gray box testing. So it improves the overall productivity. That's because you're checking the upper part of the application. At the same time, you're testing something that is there inside the application as well. So mix of black box and white box is gray box testing. Now there are three different testing techniques applied for gray box: matrix testing, regression testing, and pattern testing. Now in matrix testing, what they do is when developer writes a code, there may be some unused variables, unused data stored in variables which are not required. So when they do gray box testing, they will find these unused variables and remove it from the code. So that will optimize your code. Unwanted space that are consumed can be removed. So that is matrix testing, where unused variables are identified and are removed from the program. The second testing technique is regression testing. Regression testing is a type of test that is done on the existing functionalities whenever there is a code change. Now when developer adds a new functionalities to the software, I need to make sure that the existing functionalities are working fine. They're not impacted when this new code change is done. To ensure that there is no side effect on the existing functionalities when this new code change was done, I do regression testing. So it will take care of all the defects which can be part of the risky area, because when change is done, it might introduce some new defects and we need to find those defects. Regression testing can be done on the application side. At the same time, you can go and check the design of the application as well. And then you have pattern testing. So in pattern testing, what we do is, this is usually applied when you have a similar software being developed. Now you have developed a similar software previously, and based on the defect pattern that you have find, in the next software you try to find the same types of defects. Possibility of finding the same defects in a similar application will be high. So you have tested a software of the same type previously, you study the pattern of defects that you found in that software, and for this new software you try to find try to find similar defects. So you have a pattern to match. So that way you can find the failures or defects in the application which you had found during last similar version of the software. So that is pattern matching. So that's about black box testing, white box testing, gray box testing, and what techniques are followed in each of these testing types. What techniques we use in black box testing, white box testing, and gray box testing techniques. So that's all I have in this session. Thank you for watching, and please do visit getsoftwareservices.com for more details on the courses that we provide. Thank you so much. Subscribe and press the bell icon to never miss an update.